Sorry, I'm opening up the Excel sheet. So we're going to do 5.2, 6.3. Sorry, I'm in the wrong section. No. All right, so 6.3 is actually very, very similar to 6.2. So we're still given a curve. We're still looking for the area under curve. We're looking for a value. And the particular one that we're looking at here, it says to find the area of the shaded region. The graph to the right depicts the IQ score of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So what really changes for this one is the fact that we're now given a mean of 100 and a standard deviation of 15. It changes. We no longer have a mean of 0, standard deviation of 1. So in that, our formula changes slightly, but not really. Really, in all reality, we're just wanting to actually find a z-score now because it's not given to us. It's giving us an x value of 75. So the numbers for this particular one, we don't want, no, we don't want that. The numbers that matter are the mean, standard deviation, and x. So the area and these other two numbers over here, we're going to use them, but we're not going to use them quite yet. So you can use this table for the BASH chapter. But I'm making it now because it's more convenient to use it for this chapter because the mean and standard deviation are changing, whereas in 6.2, it's always 0 and 1. So I'm going to go ahead and set up this table. So we know that we have a mean, which I'm going to put first. We have a standard deviation, so I'm just going to abbreviate that SD. We're going to have an x value. We're going to have a z value because we need to find that. This is what we're finding. So I'm going to leave this one blank and I'm going to go over one. And this is going to be the area or the probability of that happening cumulatively. Probability. There we go. And then the next one, we're actually going to find the area again. What is this? Okay, so I'm going to just skip one over. I'm going to do area, so I'll explain each of these in a second, and then your found x. We'll do it that way, and we'll label this given area instead. Okay, so in this case, we're given the mean of 100. We have a standard deviation of 15. And then we have an x of 75. So I got all of those numbers from the problem. So I'm working on this first problem here. So we need the z-score. The z-score formula I believe I have on this page at the very top, or not. I thought I had it someplace in here, but that's okay. So your z-score formula is going to be the x value minus the standard deviation. So I'm going to put that here just so that you can see it. So it'll be the x value minus the standard deviation minus the mean. I am ahead of myself. Divided by the standard deviation. So divided by SD. That is what z equals. So z equals that. Okay. So we can actually just put that straight in here. So we're going to do equals, open parenthesis, because this is all of the numerator together. X minus the mean, close your parentheses, divided by the standard deviation. So now we have our z-score, which is good because we will always need a z-score. I'm going to go ahead and do it just the once, and then I'll explain how to find the between ones in a minute. So the area then is going to be equals norm.s.dis, which if you watch the 6.2 video, it's the same thing. Z, comma, 1, because it's true. And there's our area if it's below 7.5. And on all reality, that's probably a really good estimate. The reason it is because if we look at the picture, it's a very, very small section that is shaded. So 4% would be pretty accurate, I would think at least. So now we're going to say this is for to the left. So that's why I left this space here open. So this is calculating to the left. So it's calculating what it would normally calculate. So if I was to change this question up and I was to ask instead, what is the area of this over here? We're now calculating to the right of 75. So this is to the right. So it's still the same thing, but remember last time I said that it would have to be 1 minus and then norm.s.dist. So we can do the same thing, and I'm just going to click the Z, and I'm going to do comma 1, which is true. You can also type true, enter. And now I have that, which again is pretty accurate. That's a lot of area there, so 0.952 or 95.2%. That seems pretty accurate to me. It doesn't seem like that would be a wrong answer or anything. It looks like it would be correct. So the other thing that we did in 6.2 is between. So you're going to see something like that in these ones as well, which is why I gave a few more numbers in the X column. So I'm going to go ahead and add another one here. So I'm going to do equals, and I'm going to use the 80 value. So I'm going to do 80 in this one here, so 80. So all of these are going to be ones that you fill in. Typically, when I work with students and I'm having them fill these, I change the color because then I know like these are the ones that I'm wanting to fill in. I'm not really worried about the other ones. I just want to fill in these ones. Everything else is going to be calculated for me. So then I'm going to need to find the z-score of the 80 value. So it's going to be 80 minus the mean divided by the standard deviation. Oop, I did not click the standard deviation. We'll go back and fix it. So we want the standard deviation, and that is now our z-score for the value of 80. So if we think about where 80 would be in this, 80 is going to be probably right about here, which is probably pretty accurate. Our mean is 100, so the mean here would be 100, so it's still going to be on that left side, which means our z-score is still going to be negative because it is lower than the mean. So then last time I showed you how to put in the formula in just one line. So we're going to do that here because it'll keep our chart nice and condensed. So we're going to do equals the upper minus the lower. We have to do upper minus lower. It's just the same as subtraction. If we don't want a negative number, then we have to do the higher number minus the lower number. So equals norm.s.dist. The upper z-score minus the lower z-score. So norm.s.dist and then the lower z-score. And I'm using 1. If you want to type true, you can. That's just fine. It still gives you the same thing. Hit enter, and now we have what's between. And that would be pretty accurate because the only thing that's between here is just this little section of stuff like right there. So it looks like it would be pretty close to me. So that's how you would calculate the 3 different ways that you can do that. To the left of your given value, to the right of the given value, and between 2 different given values. So the other thing that you can do is you can find the area. So if you're given an area, so in this case I'm giving you the area of 0.9. So the area you're given is 0.9. And we're going to leave the mean and standard deviation the same. So say it's the same question and I'm saying find the area with a mean of 100 and a standard deviation of 15, find the value, so find the x, with a mean of 100, standard deviation of 15, and an area of 90%, so 0.9. So then to find your x value, you are going to, okay, it's the same thing as last time. You're doing the inverse. So again, you have to find the z-score, which this works out really well here. Okay, you're not given an x. What am I missing? Oh, that's right. Okay, so you actually use a different one, but it's still the inverse because normally you're finding an area, you're not finding a value. So when you're finding a value at a specific point, you're going to use the inverse function. So in this case, you're just going to use norm.inverse because you're not given a z-score. So the norm inverse function, I'll put it up here so that you can see it. So the norm inverse, it's going to be, put it here, equals norm inverse it's going to be the probability, so your area, then the mean, and then the standard deviation. I'm going to use SD rather than typing it out. So that's how you're going to do this, and I'll put the equal in front of here just so you're aware. And then you're going to find it. So you're going to do equal norm dot INV. And because we're doing this because we're not given an x value, so we can't use the z-score. So the probability, which is 0.9, comma, the mean, which is 100, and then the standard deviation. And voila, there we go. Now we have what the x is if we have a 90% of 119. So that is if we're looking for the 90%. I'm going to erase this so that I can start over. So if we're looking for the 90%, and like this here is 90%, so this is 90%. That's that way. So in this case, the other way that this could be stated is what is the 90% above the, if we're looking for an x value, and what's the 90% for the above x value, so to the right. So in that case, it would be something like this. So if we're saying what is x here given that the area here is 90%. So the way we do that is just do 1 minus that 90. So we are always calculating to the other side. So we know that we can find this other side because this entire thing is going to equal 100%. So that means that this side is just going to be 10%. So you can actually do that straight in this. I'm going to just line them up. So this is the left, this is the right, and I'm just going to put it here because this is the right, so we're going to do it this way. So we're going to use the same formula, equals norm.inv, and we're just going to do 1 minus that. So that's going to give us the 10%, and then we'll be on our way. And then mean, comma, standard deviation, let me click the right one, hit enter, and now we have that value in